today what we want to talk about is the binomial theorem. And it's a pretty easy goal. Our goal is to expand an example something like this, like 2x minus 5 to the 6th. Now if you're just thinking, hey, all I got to do is raise 2x to the 6th and 5 to the 6th, you don't have that quite right. So you know what that means. 2x minus 5 to the 6th means we multiply 2x minus 5 times 2x minus 5 times 2x minus 5. You see where I'm going here? Think about how much work this would actually be. Okay, how many is that? 2, 3, 4. That's just 5 of them. Then what would we have to do? Well, the methods we have now, we would just have to multiply these two together first. So that's a lot of you know that as the FOIL method, which really just represents firsts, which means 2x and 2x, outers, which means 2x and negative 5, inners, which means negative 5 and 2x, multiplied together, and last, negative 5 times negative 5. So 2x times 2x is 4x squared, 2x times negative 5 is negative 10x, negative 5 times 2x is negative 10x, and negative 5 times negative 5 is plus 25. Then you would add like terms to get 4x squared minus 20x plus 25. Then you still have 4 more of these things to deal with. Okay, what would you do next? Well, you can't call it FOIL, but essentially FOIL just means you multiply each one of these terms times each one of these terms. And then you'd still have to go back in. I'm going to do this in a different color so you can see it. That one times that one. You would get that bigger answer times this guy right here. And then we would have 3 of them left. So do you think I'm going to finish this? Goodness, no. It would take the rest of the video to finish it. And fact is, I'd probably end up with errors before it's even done because it's just so much work to do. So what I want you to realize you cannot do is raise each of these to the 6th. Whenever you're adding or subtracting, in other words, you have a binomial. 2 terms means binomial. You're adding or subtracting, that separates terms. You can't just raise each of these to a power because it's that whole thing that many times. Now if this was multiplication in here, you could certainly do that. You do 2 to the 6th, x to the 6th, and 5 to the 6th. But when you're adding and subtracting, that's a no-go. So we need a way to handle this where we don't have to multiply this huge polynomial out, okay? Now to do this, we have to stray kind of far from the topic. So I'm going to talk about some things and some definitions for a few minutes that seems like it has absolutely nothing to do with what I just showed you. So keep in mind the overall goal is to be able to multiply out a binomial raised to a high power, or even to the 3rd for that matter. But I've got to show you some stuff to build up to that. So we have these things called binomial coefficients. We have a definition right here, a binomial coefficient. It says if n and r are integers greater than or equal to 0. Okay, so n and r are just 2 numbers. They are integers. Really, they're whole numbers because they have to be greater than or equal to 0. Then the binomial coefficient is, okay, now, this is notation I feel certain you've never seen before. If you have, awesome. You're a step ahead of a lot of folks. But if you haven't, no worries. I'm going to show you everything about this. So you see these parentheses. A lot of people read this N, choose R, because it has to do with probability and counting techniques, which we are not getting into right now. But if you've ever done probability or counting techniques, you've seen this before. It's called a combination. So this is just 2 different ways of writing the same thing. You see the parentheses with N on top and R on the bottom? It means exactly the same thing as what we have to the right. The C represents the word combination of N, choose R. Notice I'm saying it the same way. What really matters is the formula, this guy right here. So anytime you see either of these notations, and I think the book uses this notation, okay, then what that means is you take n factorial, the word I'm saying there, you see that exclamation point? That is factorial. That's the word I'm saying, and that's an A. There we go, okay? And that's an A also, factorial, okay? It means n factorial over r factorial times n minus r factorial. And then you still may be thinking, oh my goodness, what in the world is she talking about? So, It's possible you've never even heard the term factorial, and that's okay. That doesn't mean you've been slighted in any way. This is often the first time students ever run into this notation. So what does factorial mean? Let's back up, okay? So right here, so what does n factorial mean? Let me give you an example. For example, 5 factorial. That is supposed to be a 5. The definition of that is you multiply 5 times 4 times 3 times 2 times 1. That's what 5 factorial means. And it's all multiplication, so you start with the number and then you go all the way down to 1. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is 120. So 5 factorial is 120. 3 factorial, as an example, would be 3 times 2 times 1. That's always what factorial means. You just write the number and you multiply all the way down to 1. So 3 times 2 is 6 times 1 is 6. So 3 factorial is 6. Some of you have that button on your calculator. You can find it. It could save you a few minutes. What I would like to do is show you how to calculate factorials where it's a little bit easier when you throw it into this combination formula. So let me give you an example of those, and let me get rid of our word factorial over here. So let's do another example. What if I gave you parentheses, 5 choose 2. So this time we're actually going to do a combination. And it also could be written C5 choose 2. Those mean the same thing. Now let's plug that in the formula. Don't worry, this isn't the only one we're going to we're going to calculate. So n factorial. So n is the first number. It's either the top number or the first number. And that goes in the numerator. So that is 5 factorial. Okay? And in the bottom, I'm doing this r factorial right here. So my r is my second number. So that's 2 factorial. Then notice it's parentheses. It says subtract them. 5 minus 2. And the factorial is on the outside. So what we need to do next is simplify the parentheses. So in the numerator, that stays 5 factorial for now. The denominator stays 2 factorial for now. We know 5 minus 2 is 3 factorial, and we're multiplying these together. By the way, 2 factorial times 3 factorial is not 6 factorial. You can't do that. It's not how it works, okay? All right, now I'm going to show you a way to simplify. Now, you could just say the top is 5 times 4 times 3 times 2 times 1. This 2 is 2 times 1, and this 3 is 3 times 2 times 1. You could do that. But I want to show you something, okay? So the top, I've got 5 times 4 times 3 times 2 times 1. I am going to write it all the way out. This 2 factorial, and put it in parentheses, is 2 times 1. And this 3 factorial is 3 times 2 times 1. Here's what I want you to notice. Is this... There's always going to be a bigger number on the top, okay? And on the bottom, there's a biggest factorial. So if you'll notice, let me highlight this for you. You've got a 5 factorial and a 3 factorial. What's going to always happen, if you write all that out, is this is going to cancel with this. So you don't even have to multiply all that out. It makes it easier. That's what I'm going to do every time I simplify them. But let me show you what you could do. In the top, instead of writing all this out that we just did, you could write the numerator as 5 times 4 times 3 factorial, because that means 3 times 2 times 1, right? Divided by 2 factorial times 3 factorial. And this 3 factorial cancels with that one. And you still have left over what we have here. So in the numerator, 5 times 4 is 20, and the denominator, 2 times 1 is 2, which means that whole answer is 10. And it feels like we have strayed so far from where we started, doesn't it? But keep in mind, in the end, this is going to help us expand those big binomials. Okay, just keep in mind. But right now, let's just focus on this combination thing called binomial coefficients. Okay, so here we have another one. You do have homework that asks you to do nothing but this. Now, you also have homework that asks you to expand 2x minus 5 to the 6th. So those are the big problems, but you have these little problems. Now, remember what this means is the top number goes on top, 7 factorial. the bottom number goes on the bottom, and then you subtract the 2. So that's, you don't feel like you got to memorize that formula, okay? Just remember the top number goes on top, the bottom number goes on the bottom, and then you subtract the 2, and that also goes in the bottom. All right, now watch this. I'm going to simplify. 7 factorial over 4 factorial times 3 factorial. You with me? I just went ahead and did the next step is to subtract. You have to do that next. Now here's the fun part to me. I really like this simplifying step. You take the top one down to the biggest factorial in the bottom. So watch this. I'm going to write 7 factorial of 7 times 6 times 5 times 4, and then I'm going to put a factorial because we know it keeps going. And in the denominator, I have 4 factorial times 3 factorial. Now how does that help? I can cancel that 4 factorial and that 4 factorial. You see what I mean? So I always count the top one down to the biggest one in the bottom. And 4 is bigger than 3. So then you can go ahead and multiply. We know 7 times 6 is 42, and 42 times 5 is 210. Okay? Or, watch this. Now I use my calculator to get that 210 because I didn't want to do that in my head. But listen, this 3 factorial down here is 3 times 2 times 1. Look what else I can do. 6 and 6. Cancels out, and you just get 7 times 5 divided by 1, which is 35. I didn't even have to use my calculator to do that. Now, I'm not telling you every time you do these you won't have to use your calculator, but there are ways to simplify these things where you can keep the numbers pretty small. So calculator's not required. Helpful, but not required. But the real trick is, again, writing the top one all the way down. What I mean by all the way down, 7 times 6 times 5 times to the biggest factorial in the bottom. Cancel those, and then write out what you have left in the denominator, and then cancel anything there you can as well. Alright, so we have another binomial coefficient to calculate here. I could read that as 10 choose 2. Again, right now I know that doesn't mean anything in terms of where does the 10 come from, where does the 2 come from. Don't worry about that. We're just plugging directly into this formula. Remember, the formula states that you put the top number on top with a factorial, the bottom number in the denominator with a factorial, and then you subtract the 2. Now, I bet you don't mind just go ahead and doing 10 minus 2 is 8 factorial, right? Because that's what, highlighter here, that's what this means. Just subtract the 2, so you can save a step. Now, remember, the next step to simplify is to write the top one all the way down to the biggest factorial in the denominator. So the top, I'm going to write 10 times 9, and then since there's an 8 factorial on the bottom, I'm going to write 8 factorial. Instead of writing all the way down 8 times 7 times 6 times 5 times, you get it. All right? In the denominator, I have 2 factorial and then times 8 factorial. Now what I can do is I can cancel this 8 factorial and that 8 factorial. And now I have 10 times 9 divided by 2 times 1. Let's write that a little neater. Okay. I can even cancel this 2 and this 10, and that leaves a 5, right? And we have 5 times 9 is 45 over 1, which is just 45. See, I did all that without a calculator. I'm not saying you have to. Matter of fact, a lot of you have buttons that have this in your calculator. And I'm not keeping you from using it. You certainly can use it, but I would love for you to just be able to do these by hand and not touch that calculator. Now, look, I wanted to show you something. This is 10 choose 2, okay? This is 10 choose 8. They're similar. You're going to see how very similar they are in just a second. So, in a different color, let's do 10 choose 8. Remember, the rule is the top number goes in the numerator, the bottom number goes in the denominator, and then you subtract the 2 in the denominator. Is that looking kind of familiar? Look, that looks just like this one, but in a different order. And remember, when you multiply, order doesn't matter. This is the same answer. Now, let's just say you didn't notice that, so you keep on cruising. So this is 10 times 9 times the biggest one in the denominator, 8 factorial, divided by 8 factorial times 2 factorial. The 8's cancel. And I've got 10 times 9 over 2 times 1, right? This 10 and 2 cancel to leave a 5, and very similar simplifying. Notice you get the same answer, and that's always going to happen. So 10 choose 2 is the same as 10 choose 8, and that's when the difference, like if I did 10 choose 7, that'd be the same as 10 choose 3. You see what I mean when those total back up? So you're always going to get the same answer there. So I didn't want you to cause alarm because you're going to notice that when we start doing these big problems. But it's just something neat to see. Alright folks, so now we're going to leave that thought just a minute. Notice I still have it in the top right corner in our square rule over here. But it says now, what in the world do binomial coefficients have to do with expanding a binomial? So let's expand these binomials. Now, this is going to get a little bit sticky, okay? So x plus y times x plus y, or we may even have to erase. That one's not so bad. Remember, use the FOIL method is what we know now anyway. So x times x is x squared. X times y is xy. Forgot my plus. Y times x is xy. And then y times y is y squared. So over here I have x squared plus 2xy plus y squared. So that is the first one. That is x plus y squared. Now, we're not going to compare it to the binomial coefficients just yet. I just wanted you to see that, okay? Now, next, let's do this in a different color. Let's do blue this time. So if I'm going to write this out to the left, x plus y to the third, that means x plus y times x plus y times x plus y, right? Okay, now we have already done some of this. This we have already multiplied out. We've got it right here. So that's essentially x squared plus 2xy plus y squared times another x plus y. And by now you're already like, I don't want to do this anymore. I know. That's why we're learning this theorem. But we're going to do it the hard way a couple of times. So x squared times x is x to the third. X squared times y is x squared. That's a plus. There we go. X squared y. Now I got to move on to this next one. 2xy times x is 2x squared y. And then 2xy times y is 2xy squared. We're still not done. Y squared times x is x, I keep writing pluses, times, plus x y squared. And then y squared times y is plus y to the third. Ooh, yuck. We've got to do this one more time, too. Now, we have some like terms here, if you'll notice. These two guys match, because they're both x squared y variables. And then these two guys match. So over here, to the right, up above, I'm going to write my final answer. X to the third plus 3x squared y plus another 3, but this time xy squared plus y to the third. So that's what happens when you have a binomial raised to the third. Okay, now, forgive me, but I'm going to torture you with this one more time. Let's take a look at x plus y to the fourth. Now, you know what that really means. That's x plus y times x plus y times x plus y times x plus y, right? Overkill, Wilson. All right, now, we have already multiplied 3 of those together, and we got what's in blue. So really, all I have to do is take what I've got in blue, x to the third, plus 3x squared y, plus 3xy squared, plus y to the third, and then multiply that times another x plus y. But that's a lot of work. Matter of fact, I'm going to move to the far left to do it. So when I multiply x to the third times x, that's x to the fourth. When I multiply x to the third times y, it's going to be x to the third y. So I've done the first term. Now I'm moving over to this term. 3x squared y times x is 3x to the third y. And then 3x squared y times y is going to be 3x squared y squared. So I've handled the second term. I'm going to get rid of the underline. Now I'm moving on to the third term. 3x y squared times x is going to be 3x squared y squared. And then 3xy squared times y is going to be 3xy to the third. All right? You following all this, or are you just waiting for me to get finished? I'm good with either one. I'm hoping you're following just in case you ever had to do this. But I'm okay if you just wait till I get finished to tell you what in the world this has to do with binomial coefficients. So y to the third times x is xy to the third. And finally, y to the third times y is plus y to the fourth. Oh my goodness, right? Now, I've got some like terms here. Can you find them? So if I highlight my like terms, these two guys match. They're both x to the third y's. And then in aqua, these guys match. X squared, y squareds. And finally, these guys down here match. Xy to the thirds. So I'm going to add those together. Now, forgive me, because I am out of space. So what I'm going to do is I'm going to remove our scratch work right here. I'm not going to do it like that. Okay, I'm going to remove our scratch work right here so I have space to write this final answer down, and then I can rectangle it off and we could take a look and see what in the world this has to do with binomial coefficients. Okay, so in red, here we go. My answer is x to the fourth plus, yeah, that's x to the third y plus 3x to the third y is going to give me 4x to the third y. So we've got those handled. And then these x squareds, y squareds is going to be 6x squared, y squared. Those are handled. Plus 4xy to the third. Those are handled. Plus y to the fourth. Okay, I'm going to rectangle that off. And there we go. Now anything that's not in a rectangle right now is just scratch work. So I'm just erasing the board. I want to get rid of all the scratch work. You see how I got it. We just knocked it out. We multiplied all that stuff out. Probably bored you to death for just a minute because I know you could do that on your own. But I just wanted you to be aware of exactly how, at this point, we know how to calculate binomial expansion. Now, as I'm erasing, why don't you take a look at those patterns? You notice any patterns going on in the final results? Look at there. Look at that erase job. Okay, so patterns. Now, let me tell you what, you know what coefficients are, right? Coefficients are the numbers in front of the variables being multiplied. So, if I make this real clear, the coefficient of x squared right here is 1. The coefficient of 2xy is 2, and the coefficient of y squared at the end is 1. So that's what we mean by binomial coefficients. For your x to the third, the coefficient of x to the third is 1. The coefficient of 3x squared y is 3. There's another 3 coefficient, and then a 1. And then finally for my x plus y to the fourth, I've got a 1, a 4, a 6, a 4, and a 1. Now that's what we mean by binomial coefficients. Now what does this weird formula have to do with that? Okay, here's what we're doing. This first binomial coefficient, this guy right here, is 2 choose 0. Turns out 2 choose 0 is 1. Let me show you why. Because remember, the top number goes on top with a factorial, the bottom number goes on the bottom with a factorial, and then you subtract them. Okay, now the 2 factorials cancel each other out, so I get 1 over 0 factorial. Y'all, I need you to know this. 0 factorial is just 1. Okay, so 2 choose 0 is 1. So that first coefficient is 2 choose 0. The next coefficient, this guy right here, is 2 choose 1. And this third coefficient is 2 choose 2. Now, if you don't believe me, let's do those calculations. What is 2 choose 1? It's 2 factorial over 1 factorial, and then remember to subtract them, over 1 factorial. Now, 2 factorial is just 2. 1 factorial and 1 factorial is just 1. You see that does give you 2 over here. Okay, then finally, let's try 2 choose 2. Again, it's just a lot of number crunching. It's 2 factorial right, over 2 factorial, and then we're supposed to subtract them. So that's 0 factorial. These two dudes cancel each other out to leave you a 1 on top. 0 factorial, remember by definition is just 1, so that gives us that 1. So those are my coefficients. 2 choose 0, 2 choose 1, 2 choose 2. Now, I'm not going to ask you where those, I haven't yet told you where the 2's and the 0's and the 1's come from yet. Just hang tight, okay? You may have your idea already. Now this guy right here, this 1, well, you're thinking that's 2 choose 0. It's also 3 choose 0. This 3 right here is 3 choose 1. This 3 right here is 3 choose 2. And this 1 right here is 3 choose 3. You see the pattern? So if you don't see the pattern yet, and by the way, you trust me on these, right? I promise you, if you plug those into that formula, the first one will give you 1, the second one will give you 3, the third one will give you 3, and the fourth one will give you 1 again. Now, how about these down here? Okay, I promise you, this first one is 4 choose 0. This 4 right here is 4 choose 1. This one right here is 4 choose 2. We'll calculate that one in a minute just so you believe me. This one right here is 4 choose 3. And this one right here is 4 choose 4. By now, you probably see the pattern. Where can I come up with these 2's, these 3's, these 4's? What are the bottom numbers? Where are they coming from? But before we get there, this one right here, I want to prove to you that that is really 6, okay? So I don't want you to just buy into what I'm saying. I want you to understand. So 4 choose 2. So we're calculating 4 choose 2. That's 4 factorial over 2 factorial, right? And then the other one that goes in the denominator is you subtract these two. So that's over 2 factorial. Keep going. All right, now what I'm supposed to do is I'm supposed to write the top one, start writing 4 times 3 times until you get to the biggest one in the denominator, which is 2 factorial. So 4 times 3 times 2 factorial over 2 factorial times 2 factorial. It's getting tiny. Those 2 factorials cancel. Okay, so that's 4 times 3 over 2 times 1, which we know is 6. Because 4 times 3 is 12, over 2 times 1 is 6. So now you believe me, and you're probably thinking I believed you before, but now you really do, right? You shouldn't believe anything I say until I prove it to you. All right, so there it is. Now, you tell me, although I can't hear you, you tell me, where did this 2 come from? So on the top, where did that 2 come from? Right there. So whatever exponent we have, that's what goes in your first position for every one of your coefficients. But look what's happening in the denominator, right? It goes from 0, then 1, then 2. That will happen every time. You will just begin to count up. You start at 0, the next one a 1, next one's 2. If you had another, it would be 3. So look at the next one. It is patterned exactly the same way. So if it's x plus y to the third, or something, doesn't matter, something to the third, then you have 3 all the way across the top for your coefficients. In the bottom, you start with 0, then it goes up to 1, and then 2, and then 3. It just counts up. And finally, look, if it's raised to the 4th, then you would have 4's across the top of every one of your coefficients. And then the choose number, or the bottom number, starts at 0 and just counts up. 0, 1, 2, 3, until you get to 4. Okay? So what if it was to the 5th? You would have 5's across the top, and then you would count 0, 1, 2, 3, 4, 5. So that's where these coefficients are going to come into play for our binomial theorem. It's also called binomial expansion. All right, folks. So I bet you're wondering why I didn't just show you this on the last page. Because all of it, look, it's all expanded. All that hard work we did where I just lost you and you were floating out in space somewhere. Here it is. So x plus y to the first is x plus y. X plus y squared is x squared plus 2xy plus y squared. X plus y to the third is x to the third plus 3x squared y plus 3xy squared plus y to the third. I'm not going to read them all. But I do want you to appreciate how much work it takes. This x plus y to the third took a while, right? X plus y to the fourth was even worse, and I didn't even bother to do x plus y to the fifth because I didn't have enough room on my PowerPoint page to even get that done. But I want you to notice the patterns. I want us to stare at these and notice the patterns. Okay? So number of terms, what do I mean by that? When you finish your expansion, when you finish multiplying it out, how many terms does it have? Well, notice this has got 2 terms, right? So x plus y to the first has 2 terms. X plus y squared has how many terms? 1, 2, 3. X plus y to the third has how many terms? 1, 2, 3, 4. X plus y to the fourth has how many terms? 1, 2, 3, 4, 5. X plus y to the fifth. How many terms do you think that the guy has? 6, right? So 1, 2, 3, 4, 5, 6. What about x plus y to the 10th? How many terms would it have? 11, you say? You'd be exactly right. So the number of terms is 1 more than the degree. You know what degree means is when you multiply it out, what's the highest power? Okay, so, or right here, there's your degree right there. Now, I shouldn't say 1 more than the degree, because here's why. Here's why. These x's and y's, they might be raised to a power, so your degree would be more than that. So it'd be 1 more than the exponent. Let's just say that. And when I say the exponent, I'm talking about this guy sitting right out here, what you're expanding. All right, now let's check this out. The degree of each term. Now, I do mean degree in that case. So when it's all multiplied out, you notice, what is the degree of this guy? 2. What is the degree of this guy? Don't say 1, because this is 1 and this is 1. And when you're multiplying, you're supposed to add those together. That's also degree 2, and this is degree 2. So the degree of each term for this one is 2. What's the degree of each term for the first one? I should have done that first. That's a 1 and that's a 1. How about the degree of this term is 3. This one is 3, right, because it's 2 and 1. This one is 3, and this one is 3. And check it out. This is matching. The degree of this one is 4. Look at here. That's 4. Those add to be 4. Those add to be 4, because remember there's a 1 right there, and that one is 4. Finally, the last one, for all 6 of these terms, that every one of them are degree 5. Degree 5, degree 5, because there's a 1. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. 5. So what would you say about the degree of each term? It matches the exponent. And again, when I refer to exponent, I'm thinking about this outside number. Now I've got lots of scribbling, so I'm going to get rid of all of this scribbling right here because I might need to write all over these things again for the next question. So you take a look at the next question while I erase. All right, the powers of x, what are they doing? Okay, so here the power of x is 1. What about your x power here? There is no x, right? So that's a 0 power of x. Look at this. This is x squared. Let's do you highlighter. X squared. That's x to the first. That's x to the 0. So that's to the first. That's x to the 0. Let's notice the pattern. Here is an x to the third, an x squared, an x to the first, an x to the 0. What are these x powers doing? X to the fourth, x to the third, x squared, x to the first, x to the 0. If you don't believe it there, check out this last one. X to the fifth, x to the fourth, x to the third, x to the second, x to the first, x to the 0. What are they doing? They're counting down. They count down from the exponent. Does that make sense? So if I had an x to the fifth, it would be an x to the, well, I do have an x to the fifth. If I had an x to the sixth, it would be an x to the sixth, x to the fifth, x to the fourth, x to the third, x squared, x to the first, x to the 0. So you count down. On the other hand, what are the powers of y doing? Let's go back and take a look at all the y's. And let's just look at the last row, because all these have the same pattern. Look, this is like y to the 0 right here. That's y to the first, y to the second, y to the third, y to the fourth, and it stops at the exponent. So the powers of y count from 0 up to the exponent. So this is going to be neat. We can do this. And what about the pattern of the coefficients? We've already talked about that. Like this would be 5, choose 0, right? This would be 5, choose 1. I'm talking about these numbers right here. This would be 5, choose 2. This would be 5, choose 3. This would be 5, choose 4. And finally, 5, choose 5. Aha! We've got it all. Now we just have to put it together. I'm going to show you one more thing in this video, and then I'm going to do a part 2 to this video where we put it all together and do full problems, okay? Alright, this is the last thing I want to show you. This is a cool trick, and I'm all about a cool trick. I want to save you time anytime I can. So, the binomial theorem, you know, all those coefficients, I've got them highlighted in red right here. So this would be like, you know, 0, choose 0, gives you that 1. This guy right here, remember the top number is whatever the expansion is, 1, choose 0. This is 1, choose 1. This one right here, remember the top number is the exponent, that'd be 2, choose 0. And then you count up, 2, choose 1, 2, choose 2. This would be 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. And the answers are what's in red. Okay? This would be 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, and 4, choose 4. Finally, for the fifth, 5, choose 0, then 5 is 5, choose 1, 10 is 5, choose 2. This 10 is 5, choose 3. Remember, if you subtract the difference, remember you get the same answer for that problem I did way back. This is 5, choose 4. And finally, 5, choose 5. Now, I want to show you something, though. If you're not a big fan of this calculation, even though you got to do it in the homework, you can't get away from it. You've got to do it. There's another way to come up with these numbers. It's called Pascal's triangle, and it's one of the coolest things ever. It's a triangle of numbers. So watch this. The top of our triangle is 1. And this part you have to memorize, and below that is 1, 1. That's how it always starts. Okay, so that part you have to memorize. Now the next row of the triangle has 3 numbers. 1 always starts a row, and to get the next number you add the 2 numbers above it together. So 1 plus 1 is 2, okay, and then 1 ends a row. Alright? Then let's do the next row, okay? Starts with a 1, then look, above it you add those numbers together. 1 plus 2 is 3, 2 plus 1 is 3, and then it ends with a 1. Okay, next row, I start with a 1. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then it ends with a 1. Here we go. Starts with a 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then, y'all, I ran out of space. A 1 goes at the very end, although it's not lined up like it should be. Now, is that looking familiar? So look, row 1 right here is x plus y to the 0 goes there. Those are your coefficients. X plus y to the first, look, my coefficients are 1, 1. X plus y squared is row 3. So notice the row is 1 more than the exponent. So row 3 is x plus y squared because there's 3 terms, right? Row 4 is x plus y to the third. So there's your 1, 3, 3, 1, just like here. 1, 3, 3, 1. Your fifth row is x plus y to the fourth. Notice again, 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. Wow. And then x plus y to the fifth is right here. Now, here's what I want you to do. What would be the coefficients for x plus y to the sixth? Well, we do one more row. It would be 1, 6, 15, 20, 15, 6, and then there's that 1 out there that I have to squeeze by. So that's kind of cool, isn't it? So you have to go to the n plus 1 row. So if you wanted to do the 6, you have to go to the 7th row. Notice that's row 1, 2, 3, 4, 5, 6, 7 gives us x plus y to the 6th. Isn't that awesome? So you could use Pascal's triangle to do these, or you could use those coefficients. Again, keep in mind, though, there are homework problems, test problems that make you know how to calculate these coefficients. So you still have to know how to calculate that. Join me for the next video where we do complete problems.